Today we're going to be talking about expanding logarithms and evaluating. There are three different properties of logarithms that we're going to be looking at here. One of them is the log of AB, so A times B, AB is being multiplied together, expands out to the log of A plus the log of B. The log of A divided by B is the log of A minus the log of B when it's expanded out. Now, I want to note that everything in the denominator is subtracted, so there might be multiple things in the denominator. They all get subtracted. And then the log of A to the B, that B comes down out front, so if there's an exponent on your argument, that B comes down out front, and it becomes B times the log of A. So, we're going to use our properties to expand the logarithms, and you'll also use them to evaluate logarithms. So when you expand, you'll always be writing more than one log or natural log. Another thing to note is that you'll have, when you're expanded, there will be no multiplication. Nothing will be multiplied together. There will be no division or no denominators. And there will also be no exponents. Another thing to note is that when your argument is a number, you want to see if you want to check to see if you can evaluate it or simplify it. So let's look at this first example here. So log base 5 of 7x. This is going to use that first property because I have 7 times x here. So 7 times x would become log base 5 of 7 plus log base 5 of x. Now I have no multiplication, I have no division and no denominators, and I also have no exponents. Now, I want to make sure log base 5 of 7, can I simplify this? So if I were to simplify this or evaluate it, that would mean, so the log base 5 of 7, let's say it's equal to something, 5 to some power equals 7? No. I have 5 squared is 25, I have 5 cubed is 125, so this cannot be simplified. So this is my answer here. Here's the second example. So everything in the numerator will be added, everything in the denominator is subtracted. So I have a 3, I have x, and I have y. So I'm going to end up with 3 different logs here. So I'm going to have the log of 3, and then plus, because that x is in the numerator, the log of x, minus, because the y is in the denominator, the log of y. Now I want to check, can the log of 3 be simplified? So that would mean that, I'll write this as a log 3 equals something. So does 10 to some power equal 3? No. So this is as simplified as it can get. The log base 3 of 2x to the 4th. So I have two things here. I have 2, and I also have x to the 4th. So I'm going to end up with 2 logs. Okay? So I'm going to have the log base 3 of 2, and then x to the fourth is in the numerator, so plus log base 3 of x to the fourth. Now this is the first time that we're seeing this rule here where I have an exponent. That exponent is a 4, so it's going to come down out front. So this becomes the log base 3 of 2 plus 4 log base 3 of x. And then I want to check, because my argument here is 2 in this first term. So can I simplify this? So is 3 to some power equal to 2? No. So this is as simplified as I can get. Next one, I have log base 3 of 3 x to the 1/2. So I'm going to have two logarithms here. One of them is log base 3 of 3, and then since the x is in the numerator, it becomes plus, it's not in the denominator, log base 3 of x to the 1/2. Now this again uses that the exponential power here, right? So this 1/2 is going to come down out front. So I have log base 3 of 3 plus 1/2 log base 3 of x. And now I want to check, can this log base 3 of 3 be simplified? So is 3 to some power equal to 3? Yes! 3 to the first is equal to 3. So this actually simplifies to 1. So this whole thing becomes 1 plus 1/2 log base 3 of x. And again, that's because this log base 3 of 3 is equal to 1. So that became 1 plus 1/2 log base 3 of x. So all factors in the denominator will have a negative sign in front of it when you expand it. So I'm going to have here, I'm going to have 4, I have x cubed, I have y, and I also have z. So I'm going to have 4 logs here. So the natural log of 4, now x cubed is in the numerator, so plus the natural log of x cubed. And since the y is in the denominator, it's going to be minus the natural log of y. And then z is also in the denominator, so minus the natural log of z. And then I have two things I need to do. The 3 right here needs to go down out front. And I need to check the natural log of 4. Can I simplify that? So if the natural log of 4 is equal to something, is e to some power equal to 4? No. So this can't be simplified at all. So this becomes the natural log of 4 plus 3 natural log of x minus the natural log of y minus the natural log of z. So how many factors does the term 3xy have? So there's 1, 3, 2 is x, 3 is y. So there are 3. How many factors does the numerator of this have? 1, 2, 3. There's still 3. How many factors does the numerator of 4ab over cd have? 1, 2, 3. Factors are things that are multiplied together to make whatever you're looking for here. In this case, it's 4ab. So that's also 3. So that's it. So now you can work on your homework.